Okay, in this video we're going to go through the process of creating a loss data set, LAS data set, or LiDAR data set really, that we will use in future analyses. The loss data set allows us to efficiently look at point cloud data without dealing necessarily with all of the data at once. And so again, let's look very quickly at our catalog view. What we're going to be using are, in this example, two data files, the 42135 LAS data set, and then I'm going to add a second one so that we can see how this works in terms of tiling, and that'll be the 42136. So what we're going to do is we're going to use our data management tools, and we're going to use the Create LAS Dataset option. Now what I'm going to do is first go through it in terms of the tools interface, and then I'm going to actually look at this from the standpoint of the model. So here we go, and first thing that we need to do is we're going to input our data files. And usually what I do is I work again from the files themselves rather than from my table of contents in my map. But again, we're going to pick an LAS data set, and it will populate. Give it just a minute. And then again, the advantage of LAS data sets is that because these are very, very large data sets, we can actually use multiple data sets more efficiently. So again, we're going to use two, and what we are interested in is, again, the LAS files. And so what I've done here is I've added two of them here. Now, the output for this is going to go right into my project 2. You'll notice that because of my working directory. And then what I'm interested in here now is adding surface constraints, and those are going to be our break line files. And so again, I'm going to click here, and we're going to find our two break line files. And again, this is not necessary. In fact, in many situations you may not have these folders or files rather available. But in this case we do, so we're going to add the two associated break line files. And in terms of our coordinate system, I encourage you to import this from your data set, and in this case I'm going to be using the break lines, which in the case of Pennsylvania actually have a coordinate system associated with them. And you'll notice that in this case it is a state plane in feet. And it's always important to understand what your coordinate systems are. Alright, so we've got that done, and we are going to compute statistics. That's very important to do eventually. You don't always have to do it at the beginning, but I think it's a good idea. We're going to store relative paths. That's also important. And we're going to click OK. Now again, these are fairly large files, and so the processing of them sometimes takes a little time, and while this is happening we will take a break. Okay, we're back and our LAS data set is complete. I want to go to our catalog view now and take a look at what you see. And so now we're in project 2, and you'll notice that here is our LASD file, and it has a different icon in terms of our catalog structure. You'll notice that it resides outside of the geodatabase. These files exist only in that format, and so it's important to understand that relationship. Now, derivatives from the LAS dataset can be stored in the geodatabase, but this is going to be stored outside the geodatabase. Alright, so we're going to take a look now at our basic characteristics. So if I look at the first thing, I'm going to look at our LAS dataset, and I'm going to look at its properties. I'm going to do this under Catalog. The first tab that I want you to notice is the statistics file. So in this case, these are the classification codes that appear. We have unassigned, ground, model key, and remember we talked about those are key points that are used in reference, water overlap, and then in this case we actually have some transmission tower data. We can look at their percentages here. We can also look at the returns here, first, second, last, single, first of many. The other point though that I want to make is as we move through these, what we are going to see is this, and this is under the LAS Files tab. And this becomes actually quite important later on when we build our information, and especially in terms of DSMs and DEMs. This is the point spacing, and the point spacing is horizontal distance on average between points, and it is in our horizontal units, so this is in feet. So the average spacing in this case is 5.4 feet for the first file, 5.3 for the second. Okay. Now, last point I want to make in this is that we can also build LAS data sets without the break line data. So I'm going to do this again. I'm going to do it on our Florida data. But before I do that, I'm going to insert a new data frame. And because, again, different LAS data sets will have different coordinate systems. So here we go. We're going to go again to create our LAS data set. And in this case, what I'm going to do is I'm going to use the Florida data set, and this is from the Florida Keys. And in this case, there is no surface constraints, so we're going to leave that alone. And we are still going to compute statistics, store a relative path, and we're going to, again, in terms of our coordinate system, one of the things that we want us to do is we want to make sure that our coordinate system is appropriate. Now in this case, what we're going to do is we're going to leave it blank, and we're going to, for the moment, and I'm going to look back in our catalog, and we're going to look, in fact, in the Florida data. You'll remember that when I opened this up, it had an XML file. So I'm going to click on that, and that XML file is going to, you'll notice right here that it identifies the projection, NAD 83 Harn, State Plane, Florida, feet. That's very important in this case because the Harn data set is somewhat different. So again, we're going to minimize that, and now we're going to set our coordinate system, and this is a rather different, something that you're not used to. Most LiDAR data sets, in fact, are going to be, at least in the United States, are going to be in state plane systems. And so in this case, we're going to be using a feet, and it is a NAD 83 Harn. And so in this case, we're going to be using the Florida. I'm going to scroll down here. And again, here's our NAD 83 Florida. And unfortunately, I need to look back at that and see exactly which one that was. And so if I bring this up again, it is Florida East. Okay, Florida East. And so here we are again, and we have our Harn, Florida East, and it's in feet. I'm going to click OK on that, and now I can run my tool. Now, if I had not set the coordinate system, the problem with that is that it also assigns our vertical characteristics. And so we actually need to set our coordinate system so that our vertical coordinates work as well as our horizontal coordinates. Now, the important thing about this set of data, these data points, in fact, have negative values because this is also bathymetric data. So in these cases, again, we can see both types of data. We don't have any of our additional information, but if we look at this data set, we can see again that we have our general information is correct, and here the important thing is that we have a LAS data set that has the correct coordinate system. Again, look back to our catalog data. Most important thing here is that we will see with our Florida data, there it is, in terms of our properties, that our point spacing, again 6.95, always an important idea, 5 million points. Our statistics, in this case, we have only 3 classes unassigned, ground and water. And we have, again, our statistics are calculated. Everything seems to be in place. Okay, so in this case, we've created 2 different types of, or 2 different LAS data sets, one of which is a very basic without any constraints. The other has constraints in it. All right. Last point I want to make here, and then we'll wrap this one up, is that when we look at LAS data sets, the advantage that they also have is at a certain scale, the data points disappear and you simply see the footprint. So don't be concerned if your data comes up looking like this. What that simply indicates is that at a given scale, the data is not visible. So here, notice that as I zoom in, point data becomes available. Now, next time, we will look at how to manipulate these LAS data sets. Till then, enjoy.